them into groups, and the entire DBU population would be divided into groups. Some groups very small, some other groups very, very big. And then we would randomly sample within the Americans, and within the Canadians, and within the Mexicans, also Senegalese, and Japanese, and Chinese, and so on and so forth. So each group would be represented. So we were guaranteed to have at least one of each nationality. Okay? So the groups will look, and this word is homogeneous. Homo meaning one or similar. Homogeneous meaning similar group. Okay? Now, the groups are similar, meaning everybody in the group is the same. These are all Americans, Mexicans, Canadians, Japanese, Korean, so on and so forth. And within the groups, they're homogeneous. But across the groups are differences. The way we say differences are heterogeneous. Hetero meaning different. Different groups. Different looking. Okay? So across the groups, within the group, similar. Across the groups, different. Within the groups, homogeneous. Across the groups, heterogeneous. Now, the final method of sampling that we're going to do, or look at, well, two more. Systematic. Systematic. Systematic you could imagine people walking down the street. And if these lines represented people, if they were walking down the street, maybe if you're systematic, every fourth person, so 1, 2, 3, 4, well, this would be, the way I have it set up would be every third person. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1. Every third person, or every fourth person, or every fifth person. This sampling technique is okay. It's the most convenient. It's easy. You can go to McDonald's and just sit out front of McDonald's and ask every fourth person a question. There could be biases. For instance, if the average family is 2 adults, 2 children for a total of 4, if you ask in this order, this could quite possibly be a husband, 2 children, and a wife. Well, these 2 people have a tendency to think the same way. And so we could get a pattern going on here, and the pattern would represent a bias. Okay, so there's lots of patterns. If you're looking at across days, and you're sampling a car, say you sample every Monday, cars manufactured in the GM plant up in Detroit, which just got shut down, or kind of shut down. If you look at the GM plant, every Monday, there's a systematic bias with warranty claims. And cars manufactured on a Monday and a Friday have higher problems and more warranty claims than cars manufactured on Tuesday, Wednesday, and Thursday. So if you're sampling every Monday, there might be a systematic bias. Or productivity. Who is the most productive on Mondays? Probably not. Also Fridays, we're very distracted when we're working, so there can be a systematic bias. And so if you do a systematic sample, you want to choose a number that will offset that. So for instance, you want to choose a day, like a 3-day cycle. So that would be every Monday, Tuesday, 'Thursday, Friday, Saturday, Sunday, Monday, Tuesday, Wednesday, and so a 3-day cycle would put you on a different day all the time, and this is a way to get around that. So these are ways to think about it. In McDonald's, you could choose a number like 15. Normally families are not 15 people wide. Even groups of friends generally don't travel in groups more than 15, so you would probably get a different sampling method. Finally, cluster sampling. Cluster sampling is very simple to think about when you think about Dallas. And so if you put Plano up here, Fort Worth, Duncanville, yeah, so on and so forth. Now, let's just mark the other cities by an X because I don't know all the cities. Irving is somewhere here, and North Richland Hills, and other X's. Now, we know that simple random sampling, if we were to randomize DFW area, and we were to get a person, and then drive to another person, drive to another person, drive to another person. Now, we just label these cities. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? And we could just pick a few of these cities randomly. We could put them in a random number generator in Excel. We could put them in a hat and shake them up. We can put them in a bingo ball crank. However, and so let's say randomly we get 7, 9, and 1. 7, 9, and 1. So that would be city X. 9 would be city X. And 1 would be North Richland Hills. Okay? So this tells me now when I go, when I cluster sample, then I choose a point and I sample within my city. This could be an apartment complex or something, and I try to ask everybody in that general vicinity. Cluster sampling is a more cost-effective way of sampling the DFW area. You still have an element of randomness by randomizing the cities, but you've now concentrated your efforts in those target areas. So much more cost-effective. When you're sampling, there's a few sampling methods that you want to watch out for that might cause a sampling bias. For instance, if I were to ask you the question, you like Barack Obama, don't you? Or, you support government health care, don't you? Not a very good way to ask a question. Or, for instance, there's no way you could be supportive of President Bush. You can't support abortion, can you? These are not good ways to ask questions. Okay? Questions should be open-ended. What do you think about abortion? What do you think about government health care? Okay? Open-ended. They should have a way to numerically judge an answer. So what do you think about government health care? Your answer should have, I'm in favor. 1, not very much. 2, little. 3, 5, I'm in huge favor of government health care. So on and so forth, so that when we get the information, it's easy for us to know what is a 1, 2, 3, 4, and 5. Okay? So we should have an easy way to be able to count that. Non-response error happens when people don't answer all your questions. Measurement error is if we are weighing, is the scale wrong? Did we get the measurements correct? Are we measuring all our samples' weights at the same time in the morning or after dinner, as water and weight fluctuate throughout the day? So these are measurement errors.